This is the first part of our analysis, that is reading and understanding the question. If you look at the question, two sets are given, set A and B. So let's first analyze the set A. Now if you focus, each element of set A is an ordered pair. What does ordered pair means? If the element is an ordered pair, it definitely means that set A represents a collection of points on a Cartesian plane. Now, if you see the second information about abscissa and ordinate is given, it is given through the inequation, and that is mod inequation, and that is mod a minus 5 is less than 1 and mod b minus 5 is less than 1, which means both are the same mod inequation. Now, as we know, equation represents curve and inequation represents region. So we can say set A represent the collection of points lying in a region. Let's call that region as region 1. Now moving to the set B, again each element here is an ordered pair, and you know what does it mean? It means again that set B represent a collection of points on Cartesian plane. Now if you see the relation between abscissa and ordinate, it is given by a 2-degree equation, and this 2-degree inequation is nothing but ellipse. So I can say that this inequation represent a region on Cartesian plane where all the points which is lying on this ellipse and inside would constitute an element of set B. So it is very clear that set A represent region 1 and set B represent region 2. Now, looking at the option, if you look, the first option says B is a subset of A, the second option says A is a subset of B, the third option says A intersecting B is phi, the third option says neither A is a subset of B nor B is a subset of A. It is very clear that the question wants you to draw both the region and then choose the best option. So concluding, we'll be needing 3 steps for this question. First, we have to solve the inequations. Second, we have to draw the regions, and third, we have to select the best option. This is the second part of our analysis. Here we are going to discuss the detailed solution, which means organizing the information given and connecting the bridge from information given to information asked. So solving the first equation, that is mod a minus 5 is less than 1. Now for solving this inequation, we'll be using the concept that mod x is less than a, where a is greater than 0. We'll be discussing this concept in our third part of analysis. So now opening mod a minus 5 less than 1, so we can say that a minus 5 will lie between minus 1 and 1. So we'll be adding plus 5 on all the sides, so we can say minus 1 plus 5 is less than a minus 5 plus 5 is less than 1 plus 5, which gives us the result that a lies between 4 and 6. And similarly, the solution of mod b minus 5 less than 1 is going to be b lies between 4 to 6. Now sketching the graph of region 1, we'll see that the a lies between 4 to 6 and b also lies between 4 to 6. Though shading these regions, we'll be getting the region 1 as our first region, that is PQRS. Now moving to the second part. Now solving the second inequation. Now the second inequation is 4 into a minus 6 whole square plus 9 into b minus 5 whole square is less than 36. Which will be simplifying it into a minus 6 whole square upon 9 plus b minus 5 whole square upon 4 is less than 1. Now we'll be using the same result of ellipse, which is x minus x1 upon x minus x1 whole square upon a square plus y minus y1 whole square upon b square equals 1. Now this represents a region bounded by an ellipse whose center is 6, 5 and length of the major axis is 6 and the length of minus axis is 4. How we arrive to this result, we'll be discussing in a greater detail in the third part. So we know PQRS is represented by region 1. For region 2, the C is 6, 5, which is the center, and A is 3, 5 and D is 9, 5, which are the endpoints of major axis, and B is 6, 3 and E is 6, 6, which are the endpoints of minor axis. So if you see the graph, A and D are the endpoints of the major axis, B and E are the endpoints of minor axis, and this region is our ellipse. Now the only contradictory point is this S and P, which we are not sure whether it lies inside or outside. So what we are going to do, we'll just take one of the two, that is P or S, and put in the equation of ellipse, and we'll see whether the equation satisfies or not. So we see 25 is less than 36, which means 4, satisfies this inequation. Similarly, if 4, 4 satisfies, then definitely 4, 6 will also satisfy due to the symmetry. So yes, we can say P and S both lie inside the region 2, which means region 1 lies totally inside region 2. And what does it mean? It means A is a subset of B, because region 1 represents A and region 2 represents B, and region 1 is lying totally inside B, which means A is lying totally inside B, which means A is a proper subset of B, and hence option 2 is the correct answer. So we can say the correct answer is option 2. This is the third part of analysis, that is finding y. As we have seen in the detailed solution, we use two concepts directly in organizing the steps. Now we'll discuss each concept in a greater detail. Concept number 1, if you remember, this we used while solving mod equation. Let's see what it is. Mod x is nothing but absolute value of a real number. So if you see mod x, if I write it as a function, if x is a positive number, it will remain mod x will become x, and if x is a negative number, mod x will become minus x. Now solving mod x is less than a, where a is a non-negative real number. For solving this, we must understand, for getting rid of mod x, we need to square, and that is why we have squared, and that is why we got, after squaring both sides, we got x square less than a square. Now we know x square is a positive number and a square is also positive number, but the question comes, can we do squaring without affecting the inequation? The answer is yes. Why? Because there is this important rule for solving an equation, that if a is greater than b is greater than 0, which means a and b are positive real numbers, then a square would be greater than b square. Why can we say so? Because fx is equal to x square is an increasing function for x greater than 0. Thus, if a and b are positive real numbers, then fa would be greater than fb, so a square would be greater than b square. Now coming back to the inequation we are solving, we know that, so we can say yes, x square is less than a square. Now if x square minus a square, we will be shifting a square on the left side, we'll get x square minus a square less than 0. Now after factorizing, what we'll get is x minus a into x plus a is less than 0. Now this expression x minus a into x plus a, we want all the values of x for which this expression remains negative. Now we'll try to draw the rough curve for x minus a into x plus a. For that, we'll be doing the wavy curve. We'll be drawing the x-axis, what you can see this green line as x-axis. Now we know that at a and minus a, this curve will intersect x-axis, so this pink curve represents our rough interpretation of x minus a into x plus a. Now since you know this pink curve, the above region would represent the positive portion and below region would represent the negative portion. Now the region between minus a and a are below x-axis, which means this is the portion which will be our solution, because on the rest of the values of x, the pink portion is lying up, which means the expression is going to be positive. But we are interested in all those values for which the expression is negative. Thus our solution stays as ax belongs to minus a into a, and thus we applied for mod a minus 5 less than 1 as minus 1 is less than a minus 5 is less than 1 in our detailed solution part. Now moving to the second concept which we used in predicting the information related to the 2-degree integration. So if you remember, that general equation of a standard ellipse is nothing but x square by a square plus y square by b square is equal to 1, where a square is greater than b square. Now this is the standard ellipse. Now if we try to draw, this curve would cut x-axis at a and b and would cut y-axis at c and d. And if you try to find the coordinate, it's going to be a comma 0 and minus a comma 0 for the coordinate b and a respectively, and 0 comma b and 0 comma minus b for d and c respectively. Now This, since it is a standard ellipse and A is greater than B, so the length of AB would be greater than the length of DC. So 2A length, the AB would qualify as a major axis, and the length of the major axis is going to be 2A, and CD would qualify as a minor axis, so the length of the minor axis is going to be 2B, and the center of this ellipse is going to be 0, 0. And the pink region, if you see this pink region, in the all the points lying on the ellipse and inside the ellipse will be represented by the inequation x squared by a squared plus y squared by b squared less than 1. Now interpreting the same result with x, thus with x minus x1 ka whole square upon a square plus y minus y whole square upon b square is equal to 1, the ellipse would remain same, but this ellipse has moved x1 units right and y1 units up. You see, the center has moved x1 unit right and y1 unit up, and thus we can say that this is how we use this concept directly in our detailed solution. Thank you.